Today I'm going to briefly walk you through number 1 and 2 of experimental design and sampling. So the first question has to deal with arsenic. So we have 8 plots here, wells 1 through 4 located next to the granite ledge, wells 5 through 8 next to the burned forest. So the first question asks why is it better to use a randomized block design than a completely randomized design? So I said that since wells 1 through 4 are all located adjacent to the granite ledge and wells 5 through 8 are located adjacent to the burned forest, if there's a difference in concentration of arsenic from either location, being the granite ledge or the burned forest, then we would want to make sure to block by location. So you want to really mention 2 things. One, that there's a difference in location, so that these 4 wells are all directly next to the granite ledge, whereas these 4 wells are all directly next to the burned forest, and that there could be a difference in concentration from the granite ledge or the burned forest. Part B then just says to identify the wells by numbers. So obviously block 1 would consist of wells 1 through 4, block 2 wells 5 through 8. And then finally, describe how to assign filters to wells to create a randomized block design. Remember, when assigning treatments, it is extremely important that you do not choose which plots or which wells in this case would receive the treatment group, being the new filter. I can't just say, okay, well, we'll do 1 and 3 receive the new and 2 and 4 receive the old. You have to randomly assign. So I went with the slips of paper here. I said I would write numbers 1 through 4 on equally sized slips of paper. I would then place these sheets of paper in a bucket, mix them up, and then select 2 pieces of paper. The first 2 slips of paper would indicate the wells that would be assigned the new filters. The remaining 2 slips would indicate the wells that would receive the old filters. I would then repeat this process for block 2, writing numbers 5 through 8 on each slip of paper to match the 4 wells in block 2. So I know it might seem silly, but you want to really include that equally sized slips of paper that you're mixing them up. Another way to go about this would be to use a coin. So let's say in block 1, you flipped a coin for each of the wells, heads being the new filter, tails being the old filter. And you could do this for each well one at a time until you receive 2 wells that would receive either the new or the old filter. So let's say you get heads, then I would stop, and the remaining ones would get the old filter. Okay, the second question actually involved a lot more probability and then just a little bit of sampling. So here's a probability distribution for the age of women applying for this STEM internship. So part A just says, what is the probability that the woman selected will not meet the age requirement for the internship? So really this is asking what is the probability a woman is selected either age 17, 18, or 19. So if we add those 3 probabilities up, we get 0.223. Now I did note here so I took this directly from the College Board rubric. So this particular part would be scored essentially correct if it's computed correctly with work shown. If you do not have any work, such as adding up the probability of each of those outcomes, then you would receive a partially correct. I think especially with this exam and there only being 2 questions, this is going to be really, really important this time around. The second part says the university will select a sample of 100 women to participate in a focus group. So part B wants to know what is the probability that at least 30% of the women in the sample will not meet the age requirement. So note here, because we have this sample of 100 women, that does imply that is binomial probability. So the formula for this is on your pink sheet. So I just said, okay, let X equal the number of women who do not meet the age requirement, and I want to find the probability X is greater than or equal to 30. So I use the formula for binomial probability, I set it up, and I finished it. Okay, so this would be an adequate amount of work to shown. I think that's about it for this. The other thing is, if you're using your calculator for this, this would be binomial CDF, and you would really want to calculate 1 minus the probability that x is less than or equal to 29. So in my calculator, I would do 1 minus binomial CDF, and then I would put, so there's 100 trials, probability of success is 0.223, and then 29. And that should give you 0.045, because your calculator reads from the x value and below. And then the final question is talking about a stratified random sample versus a simple random sample. So suppose a stratified random sample design is used to select a sample of 30 women who do not meet the age requirement and 70 women who do meet the age requirement. Based on the probability distribution, is a woman who does not meet the age requirement more likely, less likely, or equally likely to be selected with a stratified random sample than a simple random sample? So first and foremost, answer the question. So I said a woman who does not meet the age requirement is more likely to be selected with a stratified random sample. This is because the proportion of women who do not meet the age requirement at the university is 0.223. Therefore, in a simple random sample, we would expect 22.3%, or about 23 in this case, out of a sample of 100, to not meet the requirement, which is less than the 30% in the stratified. So you need to answer the question and then give some type of justification. That is all for these two questions. Of course, if you have more questions, please do not hesitate to email your teacher.